Let's start off by discussing the auto cost reference bandwidth in OSPF. So here I have 4 routers set up. One of those routers is my layer 3 switch, and this is a fictitious environment right now. My lab does not have routers with gigabit Ethernet interfaces on them, but there are routers out there that do have gigabit Ethernet interfaces on them. What's happening here is on each interface, since they're all gigabit Ethernet, they're going to have a bandwidth set of 1000 megabits per second by default. 1000 megabits per second is 1 gigabit per second. So the bandwidth is 1000 megabits per second here, which means that in OSPF will calculate the cost of each one of those links to be 1. Additionally, it's going to use a cost of 1 for the network with our end users connected to it, which is the layer 3 switches gigabit Ethernet 0/3. So all these links have a cost of 1. Let's take a look at how OSPF calculated that link cost of 1 when the link speed was 1000 megabits per second. The formula we use here is that the link cost is going to be a value called the auto cost reference bandwidth, and then we divide that by the link speed. By default, on Cisco devices, the auto cost reference bandwidth is 100 megabits per second. What this means then is when we do our calculation, we're going to take 100 megabits per second and divide it by our link speed. In this case, 1000 megabits per second. Well, when we take 100 megabits per second and divide it by 1000 megabits per second, we're left with 0.1. Well, in OSPF, we cannot have a cost that is not a whole number. When the link cost is not a whole number, we're going to round that number up. So in this case, instead of a link cost of 0.1, our link cost is actually going to be just 1. Well, what will happen then is for a 100 megabit link, the cost is also 1. If we have a 500 megabit link, the cost is also going to be 1. So effectively here, when our auto cost reference bandwidth value, the default value on a Cisco router, is set to 100 megabits per second, what we're going to get is any link that is 100 megabits per second or faster is going to get a cost in OSPF of 1. This can cause some problems. So here our 10 megabit link on our default auto cost reference bandwidth of 100 means that 10 megabits per second has a cost of 10, 100 megabits gets a cost of 1, and 1000 megabits gets a cost of 1. In the land of OSPF, the lower the cost, the better the link. So here what we're saying is effectively 100 megabit links and faster all are the same exact speed for the case of OSPF. Well, we can change our auto cost reference bandwidth. It's one of the configuration parameters in OSPF. Now that auto cost reference bandwidth, if we change it on one OSPF router, we have to change it on all the OSPF routers. So here, when we set our auto cost reference bandwidth to 1000, this time our link cost for a gigabit link is 1. Our link cost for 100 megabits is 10, and then the link cost for 10 megabits is 100. This looks much more effective at allowing us to clearly distinguish the speed difference between a 100 meg link and a gigabit link in OSPF. So we want to set our auto cost reference bandwidth in modern networks to be at least 1000. In many larger enterprise networks, we're going to have 10 gig links. Well, when we have 10 gig links, we have to change our auto cost reference bandwidth again. Should we have 10 gig links in our network and we set our auto cost reference bandwidth to 1000 megabits per second, that means that any link faster than a gigabit is going to have a cost of 1. So if we have 10 gig links here, we're going to have to change our auto cost reference bandwidth to be at least 10 gig so that we can distinguish the OSPF costs between 10 megabit, 100 megabit, 1000 megabit, and 10,000 megabits. Well, let's take a look at what this looks like now in our network environment. So if I set my auto cost reference bandwidth to be 10,000 megabits per second, what will happen now is from the perspective of router B, what we will see is we see equal cost paths to reach the device 10.0.1.10 connected to G03 of my layer 3 switch. The cost for each one of those paths from router B to network 10010 is going to be 30. A cost of 10 to get from router B to router A, another cost of 10 to get from router A to the layer 3 switch, and then another cost of 10 to get to the destination network. So we have 10 plus 10 plus 10 is 30. If we go from router B to router C, that cost is 10. Router C to the layer 3 switch is another 10. And then the network that I'm connected to on 10010 is another 10. So the cost is 30, regardless if I leave G01 of router B or G00 of router B. This creates load balanced paths to our destination network. And what that means is that if router B receives a message to reach 10010, the first packet is going to get sent out G01, the second one G00, the third one G01, and it's going to alternate every packet that router B receives destined for 10010 is going to load balance across those two interfaces. Now, this is not desirable behavior in a routing protocol. Ideally, I want to have my routing protocol choose one path as my primary path and a secondary path as the path should the primary one fail. In an ideal sense, it makes troubleshooting a lot easier because we know the preferred path for our packets, and then we also know the not preferred path for our packets. If we notice our packets taking the non-preferred path, that's a good indication that something's wrong in our network and it needs attention. So what I want to do is I want to find a way now to change the values of my bandwidth on my interfaces so that we prefer the path from router B to router A, then to the layer 3 switch, over the path that goes from router B to router C, and then to the layer 3 switch. And what I can do is I can control that behavior by modifying the configured bandwidth on each one of my links. So what I can do is on router B G00 and router C G01, I can explicitly set the bandwidth to be 500 megabits per second. And with an auto cost reference bandwidth of 10,000, that'll make my cost be 20 on that link. Now, when I set the bandwidth to be 500 megabits per second, that does not change the speed with which data is passed across my link. I'm still going to pass data across that link at a gigabit per second, but when I do my OSPF calculations for the best path, I'm only going to use the configured bandwidth on that interface. Same thing is true between router C and my layer 3 switch. And when I do this now, my preferred route is going to be from router B to router A and then to the layer 3 switch. Should I have a failure someplace in that path, then OSPF will recalculate the best path and take the other path from router B to router C to the layer 3 switch.